All right. So what I did is I wasn't sure if I made a mistake with this, so I whited it out and I want to start over on number two. But let me just talk about number one real quick. If you want Rolle's theorem to work, remember it has to be on an even playing field, where in the sense that the f of a has to equal the f of b. F of a in this case it would be f of 0. F of b is f of 4. We plug them in, and we end up getting the cube root of 4 in both instances. So that checks out. The only issue, though, is we got to make sure that it is differentiable and continuous along the whole thing. Okay. Now, what happens though is with a cube root and a raised to the second power is you might get this kind of action here on the graph. And so this right here would be an undefined slope. So this means this would be undifferentiable there. It'd be like kind of having like a sharp point, okay? So what we do is we take the derivative and we'll notice that at this point, x cannot equal 2 because if once I take the derivative, I'm going to get x minus the cube root of x minus 2 in the denominator, and that's actually going to produce a no-go with 2. Okay, and 2 unfortunately is within the domain here, so therefore you're going to get a undefined, undifferentiable slope right there on the interval. Okay, number 2, we want to find the interval here such that this guy equals 0, and let's find the value of c where it does equal 0. And we're only looking at from -1 to 3. Now what I did is I did some foiling, and I don't know if I did it right or wrong. It didn't look right to me. So I'm going to go ahead and do this. Let's FOIL. So first of all, I FOILed this guy out, so I get x squared plus 2x plus 1. That's this guy. Now I'm going to multiply it to this guy, and then that way I get a nice polynomial that I can take the derivative of. So I get x to the third power plus 2x squared plus 1. Okay, that's the x now being distributed. Now I'm going to distribute the negative 3. Okay, so that's kind of where I messed up. I was trying to go too quickly, and I had 0 coffee, so now I'm good. So I end up with x squared. These two guys combine together to get negative x squared, and then this doesn't combine with anything, if I'm not mistaken. That's 1x. Okay, wow, you gotta be careful. So that's negative 5x, and then I get a minus 3. Okay, let me just check that over again. I'm still a little low on the coffee. Can't do math and not have it. So you can speed this up, by the way. -6. Okay, so that looks good. Then these two combine for negative. Okay, so we're good. All right, that looks good. So now this is f of x, but it's not f prime of x. Let's go ahead and get f of prime. Then we're going to have to set this guy equal to 0. And we're going to get 3x squared minus 2x minus 5. Okay, and we got to set this equal to 0. It's a quadratic, so we can solve it. So 0, 3x squared minus 2x minus 5. Let's factor this guy, and we get negative 15. That adds up to negative 2, and that's negative 5 and 3. Then we divide by 3. Okay, so now we get 3x minus 5, and then we get x plus 1. Okay, now that's assuming you remember how to factor using the AC method. All right, so we got two instances, 5 over 3 and negative 1. Okay, so that is actually where this guy is actually where he's going to equal 0. Okay, so the thing though is that even though we're on a closed interval here, we want to find the value of c with an open interval, which means that it cannot equal this guy on the end because he would be an end point. Okay, so the MVT only guarantees that you have it the average value, you reach the average rate of change in the it's got to have a closed interval, but the MVT only guarantees it on the open interval. So unfortunately we cannot use -1 because it does fail this piece right here. Okay, so this means that c has to equal -5 over 3. Okay, we don't know if it's a max or a min. That's not what we're tasked to do. Okay, all right, so now for number 3, what we've got here is we have determined whether the mean value theorem can be applied to this equation right here. this guy looks like this. He's going to move over to the left 3. 1, 2, 3. He is a square root, and he's going to go this. He's going to look like that. Okay. So that you have to remember from pre-calc, and we're going from -3 all the way over there to 6. Okay, so let's make this guy here. All right. Now determine whether the mean value theorem can be applied to this guy. All right. Now first of all, find all the c values in between there. See, now notice how it's open right there. Okay, just like right here. It's open there, but it's got to be closed here to include the endpoints for the to get the average rate of change, but then it's open to find the thing in between, okay? To find the slope in between that equals that average rate of change. Okay, so we've got this, find all the values c such that, blah, 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 that the derivative here is if possible. So this is just another way of stating the derivative. Okay, so determine whether or not find all the values of c such that. So we want to know the average rate of change. All right, so let's get that. The average rate of change. Well, first of all, is this guy continuous? Yes. Okay, he's continuous. Is he differentiable on the open interval? Yes, he's differentiable. Okay, so far that's good. What's the next thing we need? We don't need Rolle's theorem. We just need to know that this guy from here to here is going to have a slope, okay? And somewhere along here, we're going to find that there's another slope that actually equals that average rate of change. And we can kind of see it's probably around 0 maybe, okay? But let's make sure, okay? So let's get the average rate of change. So let's find f of b. F of b is going to be 6. 6 plus 3 is 9. The square root of 9 is 3. Okay, so f of 6 is 3. F of -3, that's going to be square root of 0, so that's 0. Okay, so that means that the f prime of c has to equal 3 minus 0, and then 6 minus -3. So that's going to equal 3 over 9, which is 1/3. Okay, so we got a slope of 1/3. Now somewhere along that curve, we're going to have a slope of 1/3 again. Okay. All right, so let's find out what that is. So let's go ahead and take f of x, and we're going to rewrite him as x plus 3 1/2. We're going to take the derivative and set him equal to 1/3. All right, so derivative is right here. He's going to drop a degree, but the 1/2 does come in front. Okay, he's going to go -1/2. Okay, so this means that we have 1 over 2 times x plus 3 radical. Okay, so he is in the denominator because he's negative, and it has to equal 1/3. All right, so let's find out a spot here. First of all, we cannot equal... All right, looks like we have a critical value at 0. Okay, so, I'm sorry, at -3. So at -3, we can't equal, we'll get a 0, okay? But -3 right here is not an option, okay? He's at the very edge. And you can see that that is where the square root stops. So that is actually where the issue is, okay? But that means that somewhere along, though, there still is another point. So let's do some cross multiplication here. Okay, so 2 radical x plus 3 times 1 equals 3 times 1. Okay, so now let's go over here. And we're going to say square root of x plus 3 equals 3 divided by 2. Now we're going to square both sides. So now we get 9 over 4. And then we're going to subtract 3. So 9 over 4 minus 3 is the same thing as 9 over 4 minus 12 over 4, which is -3 over 4. And -3 over 4 is right about there. So I said it was close to 0 based on the graph. Kind of, sort of. He's just on the left side of the y-axis. So this is our C value, where this guy, this guy right here has the same slope as the average rate of change over that whole interval. All right, and we'll pause right there. We'll do the rest in another video.